And let's see, what time are we out of here? It started at 10:10, so that would be 10:35. Okay. So we got to get cooking. So finding vertex, axis of symmetry on a parabola, we're going to look at it on a graph, and we're also going to look at it from the standard form of the equation. Tomorrow, we'll start looking at other formats of equations of parabolas. Sorry, there's a guy washing the windows and the roof of the house next door to me. And he's got quite a contraption there. Anyways, distractions everywhere. 7.1 intro. Okay. So first, looking at parabolas, thinking about the standard form of a parabola. So for one that opens up and down, we're looking at f of x equals ax squared plus bx plus c. And of course, lots of barking. Then, so from there, we have things like the vertex and the axis of symmetry that we want to look at. If we're looking at it just from the equation, the vertex is a value hk that we can find within this equation using a formula. Tomorrow, we're going to look at something called P form or vertex form, most likely P form, that will actually have both of these a little bit more clear from the equation. And then we also have the axis of symmetry. Which is x equals h. Okay, so from standard form, you can find the value of h by going negative b over 2a. And then you can find k by just plugging in what you get for h into the equation for x. And then once you find the value of h, your axis of symmetry is just x equals h. So doing this from an equation, we're going to have f of x equals 2x squared minus 8x plus 3. Okay, so from the equation, we notice that we've got 2 is a, b is negative 8, and c is 3. So from there, we just go and plug things in to finding h, negative b over 2a. Well, negative b would be negative 8. 2a would be 2 times 2. So this would really be 8 over 4, which is 2. So then once we have our h value, we can take that and we can go plug it back in for x up here. So f of 2, because that's f of h, would be 2 times 2 squared minus 8 times 2 plus 3. So 2 times 4, which is 8, minus 16 plus 3. So that would be negative 8, negative 5. So then hk would just be 2, negative 5. This would be our vertex. And then the axis of symmetry would just be x equals the h value, which was 2. Okay. So there's vertex and axis of symmetry from an equation in standard form. Any questions from that one? This should be somewhat familiar. We're just kind of jogging our memories here. Okay. The other way around it is from a graph. So we're going to take this same thing. F of x equals 2x squared minus 8x plus 3. And we're going to take a look at it on a graph. So we're going to go over and open up a window of Desmos. And we're going to put in the graph 2x squared, or the equation 2x squared minus 8x plus 3. And here we can click on the vertex, which is nice, because then we get it the same way. The vertex is still 2, negative 5. And so then we know the vertex, and we also know the axis of symmetry. Because that's just the x value of the vertex. And we could even kind of draw, kind of what goes along with it. There's our axis of symmetry. If we were to fold along that line, we would get both sides matching up. Okay. Any questions from either of these so far? Okay. So this is just, again, these ones are only going to be facing parabolas that open up or open down. Tomorrow we're going to go over what it looks like for the parabola to open left or right. We're also going to talk about different formats of the equation that makes it a little easier for us to find things like vertex. We're also going to get some new vocab words tomorrow, like focus and directrix and things like that, and talk about how we can find equations for a parabola given different measures. But for now, we're going to leave it with this and get our assignment. Okay. So these two sections that we're doing today are Algebra 2, K1, and K2. And so we've got characteristics of quadratics from a graph and also from an equation. So you're going to see things that look just like example 1 and things that look just like example 2. Any questions, comments, concerns before we go?